Hello, we are Senior Design Team Frost 4 from the K. Gleason College of Engineering, and our project is a cryogenic heat switch for deep cycle operations. A heat switch goes in a rocket that goes up to the point where space officially meets the Earth's atmosphere. The switch needs to cool down some sensors that go inside the rocket, and it needs to withstand the vibration that the rocket experiences due to the force from the engines. The switch must be remote controlled because you cannot have someone go up with it in the rocket. One of our most significant challenges was that while this project has been attempted by 3 previous senior design teams, our team chose to scrap all existing designs and start from scratch. The heat switch will be used to connect and disconnect an Adiabatic Demagnetization Refrigerator, or ADR, to a cryogenic heat sink in a dark matter detection system, which will be launched on a small-sounding rocket. As specified by our client, the RIT Center for Detectors, the switch must withstand the vacuum of space. The harsh vibrations of the rocket launch last for at least 1,000 cycles and must be designed fail-safe if electrical power is lost. The switch must also be capable of signaling its current status to the flight computer for use in the startup and launch sequence. During the first semester, the team focused on understanding the project, evaluating different design concepts and choosing one to develop, and designing and analyzing the selected concept. Second semester work consisted of machining, building, integrating mechanical and electrical systems, function testing, vibration testing, and documentation. The mechanical heat switch has been successfully built from components machined predominantly in-house by student members of the team. The switch successfully completed all room temperature testing, including life cycle, NASA-specified vibration testing, and further characterization. Testing at final temperature and pressure is currently underway. We expect the switch to satisfy all requirements detailed to enable a safe and successful launch. The current price point for a custom switch for the Center for Detectors mission is roughly $25,000, leading them to turn to MSD for a cheaper alternative. The center is prioritizing student innovation experience, small form factor, and price point. Thus, there is no direct market for the switch being created. We would like to thank our senior design faculty guide, Professor Carlos Barrios, as well as our client from the RIT Center for Detectors, Dr. Michael Zemkov, for their helpful advice throughout the duration of this project. We would also like to thank Dale Mercado for helping the team with all things in the lab.